Alright, so we're now set up to start coding our car, and so we're going to need to apply a script to our car. Now I'm taking the script that we're using here from this great little website called Kids Can Code, and you'll see it's got a whole lot of different 2D tutorials or 2D game tutorials. I'm just going to apply part 1, part 2, some acceleration, and part 3, some friction, but you'll see that the tutorial also has some instructions on how you could add a reversing feature, which you can do yourself if you like, and also drift and slide, and so that a car would slide if it's going around corners too fast, and so you can add some code to actually add some slipping. So I'm just going to do those first 3 components, but you're welcome to visit this website and use this tutorial to add those other features as well. So we're going to have to set up some variables first of all. Let's jump back to our code. We're going to have to set up some code first of all. So we'll go to our car object, and then we're going to attach the script. And so we're going to call that script car. Make sure you've got an empty template and just push create. And this extends the character body 2D, and so we're in the right space. Now we're going to need some variables that we can then use as we're coding. And so the first thing we're going to do is set up a variable called power, and that's going to tell us the rate. Oh, I'm typing in the wrong screen. Let's try typing on the right screen. We're going to set up a variable called power, and that's going to be equal to 500, and obviously when you're setting up a variable, you should start that with var. So var power is equal to 500. Then we're going to set up an acceleration variable, and that's going to give us the direction of the variable. And so that one is actually going to be a vector2, and it's going to be set at the start equal to 0. So it's going to have no acceleration, but we're telling Godot that this is a vector, so it's a direction for our acceleration to head in. We're also going to need later on some other variables. So we're going to need a steering variable. So let's call this one var steering direction, in fact, would be a great name for our variable. And that's going to be a float, which is a type of number. And so our float is going to be a decimal number. And then we're going to need a steering angle. So the steering angle, and we're going to set our variable for a steering angle equal to 15. And so that's how much the wheel turns in degrees. Now we're going to have to do some funky maths to either make this negative 15, which would turn to the left, or positive 15, which would turn to the right within our code. And that tutorial that we run through also does some wonderful maths looking at the length of the car, because objects in Godot will steer or will turn from their center normally. But cars don't turn from their center, they turn from the front wheel. And so there's some funky maths that is in that tutorial that will actually calculate what the car should look like if it was turning from the front wheel. And so we need to know the length of our car. And so my car is about 60 pixels long, and so I've set my wheelbase equal to 60, and it's going to use that to make it look like it's turning from the front wheels instead of turning from the center. When we come to adding our friction, we're also going to need a friction value. And so this value is going to be how quick the car slows down. And so I'm setting, that means it's got to be a negative value. So our power was 500, our friction is negative 55. And so you can see it's going to take at maximum power, it's going to take about 7 or 8 seconds to slow all the way down to 0 if we have our friction value. Now we're going to start to write our procedures. So in our function physics process, that's going to be the first one we use. You'll remember that this is the process that runs every time the frame changes. We will need to, first of all, set our acceleration equal to 0, because when we change our acceleration after the first frame, we want the default to still be 0, because the person or the user isn't necessarily going to be pressing the accelerate button. And so each time the physics process runs, we want to reset the default acceleration back to 0. Then what we're going to do is run a function called getInput. And this is going to look at what keys are being pressed, and based on what keys are being pressed, it will then change the velocity and direction of our car. And so we're going to also apply friction and calculate steering in here. But let's just get our car moving first of all. So after getting the input, we're going to set our velocity and change it. So plus equals means increment by the value of the acceleration, and we're going to multiply that by delta. So that's the time since the last frame changed. And then we're going to, just like we have in our other games, call the move and slide function, which is going to initiate all of those changes. So that will be the last line in our getInput. Now we need to create that function that we've said we're going to use. So you'll see at the moment there's an error there. And so we have to actually create the function, which is going to be called getInput. And so this getInput function is going to have a look at the keys that we're pressing, and it's going to make some decisions based on the key that's being pressed. So the first key that we're going to check out is if the input dot is action pressed. There's the function I'm looking for, and so this is looking for a key that we're going to put in here, and the key I'm going to look for is the up key, and that's called UI up. So that's the user interface up, and that's one of our default keys. Now you could change this to an input just by going to the project settings, so create your own inputs if you wanted to use WASD or other keys to drive this, but I'm just using the arrow keys, and there's already an object called UI up that we can use. And so then if that UI up is being pressed, we're going to set the acceleration of our car equal to the current direction of our car along the x-axis. You'll remember we rotated our car along the x-axis, multiplied by our power value, which we've declared up here to be 500. And so that way our power value is then multiplied by the direction and gives us an acceleration variable. And we should have also finished that if statement with a colon, which is what that error was. So now we've said, here in our functions physics process, set the acceleration equal to 0, get the input. If the input is the up arrow, then the acceleration is going to change. Instead of being 0, it's now going to be equal to the direction the car is rotated, multiplied by the power. Then our velocity is going to change by this acceleration value that we just set, multiplied by the time since the last frame changed. And then we're going to initiate the move and slide. And so if we run this, we've currently got no turning, but we've now got some acceleration. So let's run our code, and if I push the accelerator key, you can see there goes my car and it'll collide, and I can't turn, but my AI car is heading off in its journey. So let's add now some left and right turning. So we're also going to need to check out whether or not the left arrow or the right arrow are being pressed. To do that, we're going to use a variable. So I'm going to press enter a couple of times. We're going to use a variable called turn. And so this turn variable is going to have a look at our input, and it's going to get axis. So this is a method that we've got that would normally look at two different actions. So you could use it with a joystick, and you could look at the left push and the right push. What I've said, I want to apply it to the left key and the right arrow key. And so this is going to look, and it's either going, if the left key is being pressed, then it's going to come back as -1. If the right key is pressed, it's going to come back as +1. And if neither key is pressed, it's going to come back as 0. And so that's going to give us a negative value for left, a positive value for right, and a 0 for nothing. And what we can then do is multiply that by our steering angle, and that's going to give us the steering direction. And so we're then going to get this beautiful little bit of mathematics, which is going to give us a steering direction simply by multiplying together the turn times the steering angle, but we want to convert it into what's called radians, because that's another way of measuring angles that Godot uses. And so this is going to take our 15 degrees and turn it into steering angle, let's do that, and turn it into radians. So it's going to either be a negative 15 in degrees or a positive 15 in degrees, but then the value is going to be converted into radians for us. And that means we've now got a steering direction that we can use in our next function. So we've got our inputs, and after our within our physics process, we're now going to calculate the steering. And so we're going to run another function, which we're simply going to call calculate steering, and we're going to pass to that the delta value, which is the time since our last frame ran, and then we can create this function down here. So I'm going to say function calculate steering, and for our calculate steering, I'm just going to copy and paste the code actually from my example I've already got. So let's copy that, and then I'll explain it because it's got some notes in it as well. So calculate steering, there we go. So what this is going to do is look at where the wheels currently are. And so the calculate steering is going to go, our position of our rear wheel will be the rotation of our car multiplied by the wheelbase divided by 2. And it's the position of our car, the position minus that. So that's going to look at the current position of the car multiplied and subtract the transformation in the x direction and multiply it by the wheelbase divided by 2, because the distance of the wheelbase is the distance from the front to the back of the car, but the position is looking at the center. So that's why we divide it by 2. And same for the front wheel. The position of the front wheel is going to be equal to the current position of the car plus the transform x times the wheelbase divided by 2. And then it's going to work out where the rear wheel and the front wheel should be. And so it's going to add on to the rear wheel the current velocity of the car. And so it's going to move the front wheel in a rotated direction. So because we've already calculated the steering direction, we can rotate the velocity in that direction, and that will give us the new position of our front wheel. And that can then be translated, so we've got a new position of a rear wheel and a front wheel, translated into a heading that we can calculate, so the direction from the rear wheel to the front wheel, and our velocity can then be multiplied by the new heading that we've just calculated by the current velocity length. And so this is going to give us a new velocity for our car, and it's going to rotate the car around as well to that new direction. And so now we've got a function here, which I took from that Kids Can Code page, that's going to calculate the new direction of our car. And so when we now run our code or run our process, we should now have some acceleration, and you'll see when I push left and right, it looks as if the car is actually steering from the front wheel instead of steering from the center, because it's each time I push the key, it's actually doing a calculation and working out where the car should be, and this calculate steering is doing that for me. Alright, now we need to have some way of slowing down. You saw there that the car just kept accelerating, there was no friction applied. And so the final little function that we're going to add in here is apply friction. So what we're going to do is, after calculate steering, we're going to calculate whether or not we need any friction to occur as well. And once again, that's going to be a function that's going to be passed the value of the delta. And our friction is a fairly small function. All it is going to be apply friction, and it's going to receive, let's put the bracket, receive the input from delta, or be passed the value of the delta, and we're going to have a variable which is going to calculate for us a friction force, and that's simply going to be equal to the current velocity multiplied by friction, so that's going to be multiplied by our negative 55 multiplied by our delta, so the time since our last frame was run. And then we're going to add this onto that's delta multiplied by delta, press enter. What's that doing? Why is enter not entering? There we go. So now we've got our, I haven't put colons at the end, there was my problem. So now I've created the function. Remember, when you write a function apply friction delta colon. And so our next line is simply going to take the acceleration value, which you'll remember we've already calculated, and it's going to change it by that friction force that we just calculated. And so now I've got something that's going to run this function, apply this friction, and it's going to slow me down as I go. And so I think I've got everything there. Getting the input, calculating the steering, applying any friction, changing our velocity by our acceleration times the last frame, moving and slide, and so we now should have something that slows us down when we release the accelerator. So let's accelerate and release, and you'll see it slows me down over time. And so rather than just being a constant acceleration, my car's narrower or slowed. When I come up behind my other car, I'll see if I can crash into it. Don't go there. There we go. I'll bounce off it because it's a physics object, and I should be able to steer around my track as I go and hopefully avoid the objects. All right, so you can add that code in for your project as well, and you should be right to run. Then if you want to, you can add those extra features.